Okay, so here they ask us to consider the equation below, and they ask how many solutions does the equation have. And the idea is that with a linear function like this, you're representing lines, and you're trying to find, when are each of these expressions equal. So if they cross somewhere, let's say you have this yellow line going along, and then this green line, right? If they have different slopes, they're going to cross somewhere and meet. So there might be one solution, x and y. So when you solve these, right, these equations and find x, you're starting to find the point when these lines really meet. But you might find that there's no solutions. In other words, you might find that when you are trying to solve this, you get a result that doesn't make any sense. In that case, it might mean that the lines never meet. In other words, they're never equal. So if you assume they're equal and try to solve it, you'll get this bizarre result, because here, when lines are parallel, they never meet. So here there's no solution, and that's when lines are parallel. The last possibility to consider with lines is in the case where lines are collinear, and that just means that they're essentially the same line. So if you have a yellow line here, and then this orange line might look different, right? They can hide their lines pretty well with some basic functions, but basically they're in the same location, therefore they have infinite solutions, and this is just called collinear. So with that being said, really what I would do here is try and solve for x and see what happens. So we have 3/4, right? Let me fix that 4. We have 3/4 times 24 minus 16x equals negative 2/3 times 18x minus 27. So what I would probably do here is distribute the fractions. I could multiply both of them by 12 to get rid of the fractions, but I think it makes more sense to just distribute the fractions and work with them. Okay, so here let's try that. So 3/4 times 24. Well, 1/4 of 24 is 6 times 3 is 18. So far we're getting whole numbers. Minus 16x times 3/4. Well, 1/4 of 16 is 4 times 3 is 12, so it's 12x. Over here, negative 2/3 times 18x. Well, think of what's 1/3 of 18? That's 9. So negative 2 of them would be negative 18, right? Excuse me. What is 1/3 of 18? That's 6, not 9. I'm thinking of the 2 here. 1/3 of 18 is 6, so 2/3 is 12, and negative 2/3 is negative 12. And then 1/3 of negative 27, right? But here we're going to get a positive result because it's a negative times a negative. So just think of 1/3 of 27. That's 9 times 2, which is 18. So now we have this equation. It's much easier to work with. But notice here, if I add 12x to both sides and try and solve for the variable, I get this odd result because in both cases the 12's cancel out. And what I get is 18 equals 18. So in this case right here, when you assume these two expressions are equal and then find that you get a result that's always equal, that means these two lines have infinite solutions. It means no matter what you do, right, you're always going to get what's called a true result here, where in this case 18 equals 18. So no matter what you plug in, these two things will be equal. And the only way they can happen is if they're really the same line, right? And they're collinear. And they are, because 3/4 of 24, of course, and 3/4 of negative 16x is equivalent to taking negative 2/3 of 18x and negative 2/3 of negative 27. And so here we get something that's always true. Alright, hope that helped.